Hello, in this short video we're going to go over some of the basics of drawing holes in 2 dimensions in orthographic views in AutoCAD Web App. So the first main type of hole that we will be dealing with are through holes. These are common. It's a single diameter all the way through. It goes through the entire block of material. These are the most basic hole can be. Next, we'll look at blind holes. And then after that, we will look at countersunk holes. And we will look at counterbore holes over here. Let's go back to our through holes. So through holes, they only need 2 pieces of information in order to be able to design them. The first thing you need to know is the location of the hole, which I've left blank here. But essentially that's usually done in the top view like this. And the locations would be attached to the center lines on the hole marking, and the view where the edge of the hole is visible in this view is an object line, so it's a visible line. So we draw the circle to the size of the hole. Typically holes are dimensioned with diameter. It's very, very, very rare you would ever see a hole dimensioned with a radius. So if it's not labeled, just assume it's diameter. And typically, if it's a through hole, it'll have something like through spelled this way, T-H-R-U. Or, moving over here, it could just say 0.75D for diameter, and it doesn't even show through, but you would just assume that it's a through hole in that instance if there's nothing else labeled otherwise. So that's what this top view looks like, where we're actually looking at the circular side of the cylinder, essentially, because the hole is just a negative cylinder. And then let's look at what the side of it looks like. It becomes a rectangle because, again, I keep using the soup can analogy. If you look at the end of a soup can, it's going to look like a circle. If you look at the side of a soup can, it's going to look more like a rectangle. So that's what we're doing here. And the relationship between the top and bottom view in this particular drawing, or top and side view, is direct, in that if I were to carefully draw a line between the left side of this hole, it would line up very precisely with the left side of the corresponding hole. This is the exact same feature here in terms of the hidden line. And the same thing goes for the right. And down the middle here, the green line is a center line. And these are different line types. You'll notice in the top view here where it's a circle, our center lines are overhanging by roughly 1/8 of an inch. That kind of scales up. If I was drawing a 2-foot diameter hole, I'd have to extend that a lot larger than 1/8 of an inch. If I was drawing an 1/8 inch hole, I'd probably make it a bit smaller of an overhang. Looking down here, our side view, because it's not a circle, we just run the center line straight down the middle, and again, overhanging it from the edge of our surface, our material here, just past the distance of the hole by roughly 1/8 of an inch. Again, sort of approximate there. These serve as places to anchor our dimensions off of. And our 0.75 hole, same story there. Let's move over here to our blind hole. Blind hole, very similar to the through hole in that it's a single diameter. There's no change in the shape of the hole. However, we have a little bit more information in our callouts here. The first is 1 inch diameter, okay? And then it gives us 2.5 dp. That dp means depth. So that's telling us that this hole, from the surface where it starts to the bottom of the hole, is 2.5 inches in depth. So it does not go through our entire 3-inch block of material. Let's look over here at our second call, 0.75 DIA for diameter, and 1.0 deep, which is pretty direct. It's telling you that the hole is 1 inch deep. And again, we can kind of see how this is lining up. And again, note that the center line just overhangs the length of the hole by a little bit on the edge of the material and then past where the hole ends. So, pretty simple. Now we're going to get into some more complicated holes. Countersunk holes. Let's look at this first set here. So that's all this over here. So let's look at the top view. Looks like 2 holes, essentially, one inside of the other. The larger hole is always going to be nearer to the surface. visibly see if it were the opposite. If it were the opposite, if we were looking at the bottom of the hole and then this were below it, this would be a hidden line. But it's an object line, so therefore it's on the top. And correspondingly, if we look down here, we notice that the wider portion of the hole is, in fact, right on the top surface. And the smaller portion of the hole, this shoulder, which is what that circle represents, is further down into the material. So a countersink basically gives you a wider spot for the head of a screw or something like that to go into where it goes below the original surface of the material. And in this case, this countersink has a 1/2 inch diameter through hole. We can see that here and through the inner circle. A 90-degree countersink, which means that the sides of the countersink are 90 degrees apart, symmetrical about our center line here. And 0.75 deep, that measures the depth of the countersink from the top surface of the material to the shoulder where it transitions to our through hole in this case. Showing this dimension here is also critical. And what does the whole thing look like? We've got our angled hidden lines showing the countersink. We have a hidden line straight across here denoting the shoulder, the transition, the sharp corner that's created when we transition from our countersink to our actual through hole. And then hidden lines that go down straight through the through hole all the way to the other surface. And again, center lines that go and extend a little bit beyond the actual hole itself. And again, at the top, a single center line going across both circles, denoting that these are one continuous feature. Look over here. 1/2 inch diameter through, 120 degree countersink, 1 inch diameter. Identical top views here, but when we look at our front view, you see we get a very different result. The through hole is the same, however, we lose a lot of depth due to the 120 degree angle, much shallower depth because of that. And then it's measured off of the top being 1 inch this time instead of measuring the depth. That is another way to do it. And then last but not least, we've got 1/2 inch diameter, 1.25 inch deep total. So that's saying both the countersink and the hole, total depth, 1.25 inch. Our countersink is 60 degrees, and that is 1/4 inch deep. So we can kind of see that play out here. Again, our angled sides of our countersink are 60 degrees apart, centered about our center line, symmetrical. And then the total countersink is 1/4 inch deep. So if we increase the depth, the width of the hole would get greater. However, our bottom here is at 1.25 inch due to the beginning of the call out saying that it is 1.25 inch deep total. Moving on to counter bores. Counter bores are similar to countersinks, except that they have squared up shoulders. These are more for like bolts. You'll see these more in a metal application than in a wood application like you would with countersinks. So if we look at our first one, we've got 1/2 inch diameter through. Again, same thing. 1 inch diameter counter bore, same as last time. 2.5 inches deep. Now this 2.5 inches deep because it's after the counter bore call out actually means that the counter bore itself is 2.5 inches deep, not the through hole, because the through hole goes all the way through our 3 inches of material. So again, our top looks very similar to last time, but if we look down at the bottom, we're getting much different results here because of our 2.5 inch depth, 1 inch diameter counter bore. Our through hole is in fact only 1/2 inch long. Let's look at the same top view here on all three of these. 1/2 inch diameter through hole, 1 inch diameter counter bore. We're going to repeat that on the third one as well. However, our counter bore here is 1/4 inch deep. So let's look at what that does for us. So we've literally moved the decimal place over to the left here 1, resulting in 1/4 inch depth measurement now. So it's 1/10 of that. And you can see the drastic difference we get. We're taking the shoulder and we're moving it up 90% of the way toward the surface. This is probably the more common setup you'd see for a counterbored hole where the counterbore is a little shallower compared to the through hole. Let's look at our last one. 1/2 inch diameter, 1 inch deep hole. Okay, so the depth measurement here it comes before the counterbore call out. So that's referring to our primary hole here, our 1/2 inch hole. And then our 1 inch diameter counterbore is only 1/8 of an inch or 0.125 deep. That's sort of like a spot face. It's meant to see a washer or something like that. And again, you can kind of see what this looks like here with our hidden line going all the way across the transition point, just like it has in the other examples as well. And again, our center lines as always. So that is the basics of drawing holes.